Now let's continue. All right, so we already talked about MPS, which is basically Master Production Schedule, which is one of the key elements within the whole MRP system. All right, so MPS basically is helping us to get the brief idea about, how we fit our operational or sales plan by using our current MRP system. So basically, you can view it as the connection between the general sales and operational plan and your detailed MRP system. Within the MRP system, there are three key elements that we have to, fully discuss about. The first one is MPS, Master Production Schedule. We already talked about it, all right? Besides that, all right, bill of material and also inventory records are another two key elements within the MRP system, okay? So here we will start to expand the whole MRP system. That's why we moved to the MRP explosion process. Okay, we will first talk about bill of material and then we'll move to inventory records. Okay, we will talk about both dimensions in detail. All right, let's start from the bill of material. As you can clearly see here, bill of materials basically is a record of all the components of an item, okay, the parent and the component relationships, and the usage of quantities derived from engineering and process designs. All right, so here, let me give you a quick example, okay, to illustrate the bill of material. Okay, suppose right now we are trying to manufacturing ladder back chair for our customers. All right, so as you can clearly see here, for every ladder back chair showing here, okay, you may need some back legs, front legs, right? Back slats, leg supports, seat cushion, seat frame boards. All those things are components to basically assembly for this finished product, which is the ladder back chair. Okay, so if we turn into bill of material structure, okay, then clearly you can see that basically in order to produce one ladder back chair, actually you need, okay, one ladder back subassembly, which is B, one seat subassembly, which is C, two front legs and four leg supports. Okay, so basically in order to complete 1A, you need actually 1B, 1C, 2D, and 4E. Okay. Now let's continue. So, however, in order to get one ladder back subassembly, you first need to prepare two back legs and four back slats. So that's why here you see basically in order to get 1B, you need 2F and 4G. All right. Here, if we move to the subassembly process for 1C, you can see that you need to further prepare 1H and 1I. All right. And in order to get 1H, you actually need 4J. Basically 4 seat frame boards here in order to prepare 1H, okay? So bill of material generally conveys two very important type of information, okay? The first type of information is about the relationship between the parent and the component product, all right? And the second key information that bill of material is conveying is about when I try to prepare for the corresponding parent product, all right? How many components I need to prepare. Okay, so basically these are the two key informations that we will include within the bill of material. All right. Now, as you can clearly see here, within the bill of material, they try to classify different items into different classifications. All right. They gave end items, intermediate items, sub-assemblies, and purchase items. All right. Let's use the example that we just covered to basically illustrate the key idea of all these different four terms. All right. The first one is called end items. All right. So within our example, what means by end item? Very simple. Okay. If this item is only playing the role of parent product, not component product, all right, then they should be viewed as the end item. Okay. What is the corresponding item that's only playing the role of parent product? Of course, ladder back chair A itself basically is only playing the role of parent product instead of component product, right? Because A itself is not a component of any other things, right? So A can be viewed as an end item. All right, now let's move on. So the next one is called intermediate items. Very simple. The intermediate item basically is representing every item that is playing both the parent and the component role within this whole MRP system. All right, now let's look at this structure again by using this example. All right, so we know that basically here it's very straightforward, right? B, C, and H, these three items, okay, are playing both the parent and component role. Why? Very simple. Here, if you look at B, B is a parent of F and G, however, it's a component of A, right? C is a parent of H and I, however, it's a component of A, all right? H is a parent of J, however, it's a component of C, okay? So that's why here, B, C, and H, these three items can be viewed as intermediate item, okay? And that's why you see we use the same color here to represent these three different items, okay? Now let's continue. So another related concept is called subassemblies, okay? First of all, if one item is viewed as subassembly, then it should be also belong to an intermediate item. So a subassembly basically is an intermediate item that is assembled from more than one component. Okay, so here, if we go to this example, we already know that B, C, and H, these three items are intermediate item. Okay, and among these three items, which items actually are assembled from more than one component? If you look at the three, of course, B and C, all right? B is actually, every B needs to assemble from F and G, right? Every C actually needs to assemble from H and I. However, H is only assembled by, seat frame boards, which is J, okay? So that's why here, among these three intermediate items, okay, B and C are further viewed as subassemblies, okay? So that's actually a very close relationship between intermediate item and a subassembly. Now, let's continue. The purchase items. Purchase items, very simple. If this item in this whole structure, okay, is only playing the role of component product, all right, then we view it as the purchased item. Basically, you buy it from your supplier and then you use it for, assembly and in order to get the final product, okay? So F, G, J, I, D, E, all these things, you see, they're only playing the role of component item, all right, instead of parent item. So that's why all those different, which are represented by the purple, okay, are viewed as the purchase items. So this will be a main illustration of bill of material, which conveys the core idea of the structural relationship between the parent's products and the component products. All right, now let's continue. So here, let's talk about another very key element within the MRP system, which is called inventory record. Okay, this will be a record that shows an item's lot size policy, lead time, and various time phase data. All right, now let me use one specific example to illustrate the key idea of inventory records. Okay, of course, it will include all these different terms within the specific inventory records. All right, now let's start. So first of all, you can clearly see that actually the format of the inventory record is very similar as the format of the MPS schedule process, right? So here, I basically just provide you the inventory records for the seat subassembly, which is item C, as an illustration. Okay, now you can clearly see that at the lot size 230 units and lead time is 2 weeks. Suppose we were to use some inventory management, quantitative methods to get this amount, okay, which is basically representing an appropriate lot size amount. All right, then how we connect inventory management with the MRP system, that's what we will talk about within this inventory record. All right, now you can see that we have 5 different terms showing within different roles, okay? But the key idea here is very similar as what we already mentioned within the MPS process. All right, let me detailedly talk about it. So basically, in the most general big picture point of view, all right, what we are calculating here is basically how much inventory we currently have, plus how much new inventory we will get in this period, minus how much inventory we need to basically send it to the customer or send it to the production line in order to produce for the corresponding parent products. All right, and the left amount will be the inventory amount at the end of this period. Okay, so that will be the key idea here that we go through this whole flow through different periods. Now, suppose that here, this item C, basically the seat subassembly, is for both the ladder chair products. Okay, let me show you. So suppose this item C is for, both the ladder back chair and also the kitchen chair. Okay, so basically, if we assume that for every ladder back chair and also kitchen chair, they need one subassembly. Okay, then that's why you see here, when we look at the gross requirements, as we show here, right? The gross requirements, we need actually 150, all right? Ladder back chair in week 1, we need another 120 kitchen chair in week 4, right? We also need another 150 ladder back chair in week 6, and then we need another 120 kitchen chair in week 7. Okay, suppose that for every, no matter ladder back chair or kitchen chair, we need one subassembly. And that's why here, if you look at this specific inventory record, right, we also need 150 subassembly in week 1, 120 subassembly in week 4, 150 subassembly in week 6, and 120 subassembly in week 7. Okay, so that will be the corresponding growth requirement for the seat subassembly. All right. Now, before we jump into the specific calculation details about the flow within different specific periods, all right, I would like to first clarify the difference between scheduled receipts and planned receipts. Okay, actually, their difference is kind of subtle, all right, but it's also very clear. So for the scheduled receipt, basically, this is corresponding to those amounts that are already on schedule. For example, you have already signed a contract with your supplier to basically order a certain amount from their factory to your warehouse. Okay, so in very rare case, this amount can be changed during the process. All right. However, opposed to that, basically the planned receipt, this amount basically is a new amount that's in your plan. You may actually order it from the supplier, but you haven't actually make any promise or you haven't actually signed any contract with your supplier. Okay, so the amount showing within this specific row, basically you can change the amount due to the real fluctuation during this whole period. Okay, so that would be the subtle difference between scheduled receipt and planned receipt. Okay, another term is called planned order releases. The only reason that actually we also need to put in the specific information related to planned order releases each time when you have some planned order amount, right, is because basically you need some ship time or we call lead time for the supplier to ship the new amount from their factory back to your warehouse. Okay, it will not automatically come to your warehouse. It will take some time. So that's basically also will impact how you plan, you replenish some new amount to your factory, to a warehouse. All right, now let's start to talk about the calculation flow within different periods. Now we start from the 37, basically it's representing the beginning inventory of this subassembly C within your warehouse at the beginning of week 1. Okay, now here, suppose we know that basically within week 1, you have some scheduled receipt of new amount, which is 230. Okay, do you have any planned receipt? No, this is basically showing 0 here. All right, now, so the total amount of inventory that is available to you for subassembly C will be 37 plus 230. All right, however, you also know that basically we need 150 units of subassembly C for the further production of ladder back chair. Okay, so after this week 1's process, okay, what is the ending inventory within your warehouse? Okay, that is basically available for some further production or further sales. Very simple, right? Basically, you use 37 plus 230. That's the total amount that is available to you before you give certain amount to fit for the growth requirement of the producing, ladder back chair, which is basically 150, right? So that's why here, see, in order to calculate any inventory, you basically use 37 plus 230 minus 150 to get the 117. Okay, so that's why this ending inventory shown here is 117. Okay, that's your projected on-hand inventory. Essentially, it's representing the ending inventory within this specific period. Now, if we move to the second week, all right, so your beginning inventory as the week 2 will be 117. Right? Because this is basically equivalent to the ending inventory within the previous period. So that's why this is 170. Okay. Do you have some new amounts that will, ship to you? You don't actually have any scheduled receipt. You don't actually have any planned receipt. So basically, this will be the total amount that is available to you. Okay. Do you have any requirement that you have to, use some of your sub-assembly amounts to basically to fit for some new production plan? No, this is 0 shown here. So that's why here you see, finally, the ending inventory within week 2 is still 117. Okay, and then here you see the same logic is for week 3. Okay, now we know that at the end of week 3, the ending inventory is 117. All right, suppose there's no, new inventory coming to your, warehouse, right? Then the total amount that within the week 4 is still 117. However, we know that the gross requirement in week 4 is 120. Okay, so if we directly calculate following this, the same way within week 1, week 2, and week 3, what will be the ending inventory within week 4? It should be -3. Why? Because at the beginning you have 117. Without any new replenishment amount, you use 120, then you directly use 117 minus 120 to get this -3. Okay, what this -3 means? -3 represents your ending inventory within week 4. Okay, basically you have -3 ending inventory. Okay, so mathematically you can use -3 here, but actually we all know that inventory amount has to be a non-negative amount, right? But here the negative value showing here at least show you a very strong, signal. It tells you that your inventory will have some shortage situation if you do not actually replenish any new amount here. Okay, now suppose we do not replenish anything through this whole process. Okay, let's continue. Now, within the week 5, right, the -3 is basically any inventory in week 4, and also it can be viewed as the beginning inventory within week 5, right? And do you have any new replenishment? No, we don't actually have any new replenishment, right? Do you have any new gross requirement? No. So that's why you see any inventory is still -3. Okay. However, if we move to week 6, right, without any new replenishment, you further need to use another 150 requirement for, producing leather bag chairs, right? So that's why you see any inventory will be further moved to a more negative amount, which will be -153. Okay, the same logic for week 7. You will find out that if we further use another 120 to basically produce for a kitchen chair, your any inventory of subassembly will be -273. Okay, and then finally within week 8, without any new replenishment and also without any new usage of your subassembly, your end inventory will be -273. Okay, so without any replenishment, the inventory records is showing like this way. However, okay, we cannot actually keep the inventory record like this. We have to do some adjustment. Okay, basically it's corresponding to the replenishment plan. Okay, how we do the replenishment plan? Very simple. Okay, this will be the specific process how we get every number. Okay, for projects, on-hand inventory showing within this specific role. Okay, exactly as what we just mentioned. Now here, let me show you, the updated inventory record after we basically have some replenishment plan. Okay, so you may still remember at the beginning. Okay, I tell you guys that basically here, suppose we already use some appropriate, inventory management quantitative method to get the appropriate lot size, which is 230 units. Okay, and also the lead time is 2 weeks within this specific example. Now, here we know that within week 4, okay, we will have some shortage in inventory, which is -3. Okay, basically, in order to get rid of this, shortage situation, what we need to do, we have to replenish some new amount in this specific week, right? So here, since each time when we try to replenish, the amount that we will get is 230. So that's why here, in order to get rid of the negative situation for inventory within week 4, you have to further replenish another 230 units within this week. Okay, but here, very important thing is that we know that, even if you want this amount in this week 4, it will not automatically come to your warehouse, right? So that's why here, if we want to get this specific amount in week 4, you have to, start your plan within week 2 because the lead time is 2 weeks. Okay, so basically, essentially, it means that you have to order this 230 new units from your supplier in week 2, and then they probably will ship 2 weeks, and then in week 4, you will get this new amount. Okay. And then you can compensate for the shortage of the inventory. Okay, after you get this new amount, you see basically at the beginning of this specific week 4, you have 117 because this is basically also the ending inventory within the previous period, right? And then you have this new 230 units, you add it up minus the amount that you have to use it for production plan. Then the corresponding result will be 227. Okay, simply saying is that 117 plus 230, that's your total inventory available amount, and then minus 120. that will give you a positive amount. Okay, so with replenishment, you will get a positive amount instead of this, negative amount. All right, now let's continue. So after you have this positive amount, right, in the next week, there's nothing happened here, right? So that's why the ending inventory is still 227. All right, now if we move to week 6, let's continue. All right, so in this specific, do you get any new replenishment? No, you don't actually get any scheduled receipt or planned receipt. Okay, do you need to use some of them to produce some finished product? Yes, you need to use 150, right? That's why you use 227 minus 150, you get 77, which is basically the ending inventory within that specific period. Okay, now let's move on. So here, without any new replenishment, okay, we know that in the next period, which is week 7, you will also need to use another 120. Okay, currently we only have 77 as ending inventory. If we want to use 120, what will happen? You will have a shortage. Okay, and if we do not actually replenish, this ending inventory will become a negative value, right? That's actually very straightforward. So that's why here we also need to do another new replenishment process. Okay, and we know each time when we have new replenishment process, we need to order 230 based on the lot size rule. Okay, so that's why here you see there's another 230 amount as the new planned receipt here. And if we want to receive this new amount, we have to plan it. We have to order it 2 weeks before, right? Since we want to receive it in week 7, that's why we order it at week 5. Okay, so the key logic here is very simple. And once you get this 230 units in week 7, okay, the ending inventory is 77 in previous period, right? You further add up this 230, that will be the total inventory amount that you have, and then minus the gross requirement that is for production plan. Then the remaining amount sitting within your warehouse after all the things happening will be 187. You can double check the specific amount, okay? And since in week 8 nothing happens, the end inventory is still 187. So this will be a whole, informational flow about how this inventory records will change, in different periods. Okay, given that we have this replenishment process. Okay, because we want to have the replenishment process basically is to get rid of the inventory shortage situation, right? We want to fit our production plan as much as possible, as smooth as possible. All right, so that would be the key idea here. If you have any question, feel free to let me know. All right, now let's move on. Now here comes the planning factors. Basically, we all know that many different types of the factors may impact the MRP system procedure and also the efficiency. All right, so among all those different factors, at least 2 very important dimensions needs to be incorporated, which are related to lead time and also the order quantity amounts or recorded lot size amounts. All right, we detailedly talk about these 2 key dimensions within the inventory management process. Here, still the same thing. Within the MRP system, we also need to take care of the the lead time process procedure and also the order quantity amount procedure. All right. So first of all, as to the lead time, as you can clearly see here, when we plan lead time, it will actually consist of estimate for setup time, processing time, materials handling time between operations, or waiting time. The text will already show us a very clear explanation about how each time may actually impact the planning lead time procedure. I won't actually repeat it. Okay, please look at the textbook carefully. All right, and then another very important dimension that I would like to emphasize, that would be the lot size rule. Okay, basically the order amount rule. Okay, within the inventory management process, we actually already discussed about different quantitative methods. We discussed about fixed order quantity model. We discussed about the fixed time period model. All right, all the different models basically is trying to help you get the most appropriate order amount. Okay, that may actually help you to minimize the inventory cost, minimize this, the holding cost or setup cost in different dimensions, right, through this whole process. Here, within the MRP system, we still need to take care of the lot sizing rule, okay? Here, first of all, if we use the fixed order quantity rule, right, we basically, each time when we order some amount, we order the fixed amount. The specific fixed amount can be determined by either quantity discount level, the truckload capacity, the minimum purchase quantity, or EOQ, which actually we already talked about how to calculate EOQ, right? The economic order quantity. So you can actually determine by all these different factors. Okay, here, suppose given those specific criteria, okay, you already know the specific fixed amount that you order each time when you try to replenish, right? Based on the previous example, right, we already give you a very clear example about how basically we use the fixed order quantity lot size rule to go through the, the inventory records, to go through the MPS procedure. Okay, so you already get a very solid understanding about how we use fixed order quantity rule within this whole MRP system. Now, but fixed order quantity rule is not the only rule that we can apply, all right? As we mentioned within the inventory management chapter, right, we can also use the periodic order quantity rule, all right? So you may still remember, for the periodic order quantity rule, the time interval of each order quantity behavior is fixed. However, the order amount itself can be flexible when each time when I try to order from my supplier, okay? Then within the periodic order quantity, how we basically determine the most appropriate POQ lot size? Very simple. Here we actually list the equation, all right? So first of all, you need to calculate what is the total gross requirements for each interval time, may include P weeks. And then you further need to clarify what will be the current inventory on hand, okay? Then the difference will become the new periodic order quantity lot size amount that you need to order from your supplier, okay? Let me give you a quick example to illustrate, all right, the whole idea showing here. Suppose we still use the example that we just covered, but instead of using the fixed order quantity lot size rule, here we use the periodic lot size rule, okay? Suppose we assume that the periodic interval time equals 3. That's why I show here P equals 3, okay? What would be the most appropriate POQ lot size given that rule? Very simple. Here, you see this figure, right? Here, there's still this key information, at least for the first 3 weeks, will be exactly the same. You may still remember that we did this specific example, right? If we do not replenish anything, we will have shortage within week 4. Okay, here, still the same information, okay? But the specific replenish amounts based on the periodic order quantity rule will be different, okay? How we calculate the specific amounts, very simple. When we stand at the beginning of week 4, okay, since the time interval of the periodic replenishment plan is 3 weeks, right? So basically, I will not actually look at the inventory situation within week 4, week 5, and week 6, okay? So, but we also need to basically cover the gross requirement within the 3 weeks, okay? What is the gross requirements within week 4, week 5, and also week 6? Very simple, use 120 plus 0 plus 150, which will be 270, right? That's why you see 120 plus 0 plus 150, that will give you the gross requirement for the next 3 weeks when we stand at the beginning of week 4. Okay, and also we know that at the beginning of week 4 or equivalently at the end of week 3, okay, the corresponding inventory is how much? Is 117, okay? So then you simply calculate the difference between these two. So this 153 units will be exactly the amount that you need to replenish at the beginning of week 4 in order to follow the replenishment plan based on the periodic order quantity rule. Okay, now if we put this 153 units into the specific table, all right, now suppose that lead time is not affected, it's still 2 weeks, all right. In order to get this 153 units, you have to basically order it as week 2, right? 153. That's why we have this 153 showing here for plan order releases. And then for another 2 weeks shipping time, you see that 153 units will be received right here. All right, now let's see how this specific amount will impact all of the following flow of information. Okay, very simple. First of all, we know that basically at the beginning of this week we have 117 units of inventory, right? And then if we replenish 153 new units, all right, and then since we use another 120 to basically produce for the kitchen chair, right? Then what is the remaining amount of item C? Very simple, right? You use 117 plus 153 minus 120, you will get this 150 units. This will become the ending inventory. Now, since within week 5, does anything happen in week 5? No, nothing happens. There's no new replenishment nor new planning product requirements, right? That's why you can see that finally the ending inventory within week 5 is still 150. All right, then if we move to week 6, all right, you see that basically here, there's no new replenishment, all right? However, the gross requirement within week 6 is exactly 150, right? Then basically you use all of your current inventory for the production plan, right? Then finally, you see your projected on-hand inventory at the end of week 6 is 0, okay? So that's basically how the periodic order quantity rule will impact the following, information flow. All right, now let's continue. So besides these two very common order quantity rule, okay, here I would also like to introduce another rule called law for lot rule. Actually, the essence of law for lot rule is very clear and very simple. Okay, basically, in the law for lot rule, they try to get rid of the inventory, try to minimize the inventory. All right, and each time they will only replenish the amount that they think is necessary for the new production requirement. Okay, so how we basically replenish based on the law for lot rule? Very simple. You guys may still remember that when we talk about these inventory records, right? Without any replenishment, we will show some negative values within this following weeks, right? So if we use the law for lot rule, we will only try to replenish the exact amount that we need in this specific period. Okay, let's still go back to this example to illustrate the main point here. Okay, you may still remember that without any replenishment, actually any inventory within week 4 would be -3. Okay, suppose we use law for lot rule. In order to get rid of the shortage, okay, we just need to replenish another 3 units in order to get rid of the shortage, right? So that's why you see, you basically, by using law for lot rule, you just need to receive another 3 amounts, in week 4, okay? And in order to receive these 3 units, you need to order it 2 weeks before, which is week 2, okay? Now, within week 5, do you have any inventory? No, you don't actually have any inventory, all right? Do you replenish new amount? No, you do not actually replenish any new amount. Do you have any new production requirement? No, you do not actually have any new product requirement. So that's why you see in all these 4 different cells, okay, all of them are 0. Now, if we keep using law for lot rule, if we move to week 6, okay, how we deal with it? Very simple. We know that basically at the beginning of week 6, there's no inventory within your hands, all right? And do you have any, production plan? Yes, you have some production plan, okay? So in order to basically fit for this new production plan, you better, have another 150 units of new inventory that actually come into your factory, right? But in order to get this 150 new units, you need to basically order it 2 weeks ago, which is basically week 4, okay? So you see that here, we still use law for lot rule to basically compensate for the new production plan, okay? But we do not actually order any one single extra unit, okay? Because we just want to fit for that target, okay? And the same logic here is for week 7. That's why you replenish another 120 in week 7, okay? But in order to get this 120 units, you need to order it, 2 weeks before, which is week 5. So this will be the main illustration about how we apply law for lot rule within this MRP system. Okay, the key sense is very straightforward. Basically, when we apply law for lot rule, you will order some new amount only when the new production plan actually needs some new replenishment. And the replenishment amount will be exactly the difference between your current inventory and your new production requirement amount. All right. After I illustrate all those 3 different rules, okay, let's compare these 3 rules. We already introduced fixed order quantity rule. We already introduced the periodic order quantity rule, and also we introduced the law for lot rule. Here we know that basically following our example shown here, right? Our replenishment process actually starting from week 4. Okay, within law for lot rule, we know that you won't actually hold inventory because you basically provide the exact amount that you need within that specific period, right? So that's why in this 5 specific periods, your inventory is always zero, okay? However, if you move to the periodic rule, right? Starting from week 4, we know we have some replenishment, okay? And the average inventory within this 5 weeks will be 150 plus 150 plus 0 plus 0 plus 0 divided by 5, okay? Which is exactly shown here, okay? And if we move to fixed order quantity rule, and you can see that the corresponding inventory is shown here, and you can clearly calculate the corresponding average inventory, okay? Which is showing here, okay? So if you look at the average inventory level, okay, by following fixed order quantity, periodic order quantity, and lot for lot quantity rule, all right, you can see that basically here, if we follow fixed order quantity rule, okay, the average inventory that you hold within your hands during this whole process will be higher compared to POQ, which is periodic order quantity rule, and also higher compared to lot for lot rule, because in lot for lot rule, basically you will not hold any inventory within your warehouse. Okay, so what is the advantage and also what is the disadvantage of using every single rule? Very simple. It's very clear that in this specific example, given the statistics, right, you can clearly see that basically the average inventory level by using fixed order quantity rule will be much higher compared to the amounts by using periodic order quantity and also lot for lot rule, okay? So what is the advantage of having more inventory within your warehouse, and what is the disadvantage of having more inventory within your warehouse? It's actually very straightforward, right? We already talked about that within the inventory management process, right? So basically, if you have more inventory, you can better prepare for any unexpected situation, okay? So that would be good. But you need to hold during this whole process, right? That's why you need to incur more holding costs through this whole process. That would be the downside of having more inventory, okay? On the other extreme, we all know that basically if we use a lot for lot rule, basically you do not hold any inventory within your warehouse during this whole process, right? Each time, if you need this amount, you exactly provide this amount, okay? Well, first of all, the good thing is that you do not actually have to hold any inventory. You get rid of the inventory holding cost, okay? However, the bad thing is that when the market demand realization is not that stable, okay? Especially when the market demand realization is very fluctuated, okay? Since you do not actually have any inventory within your warehouse, you will face high risk of having stock out situation, okay? So you will lose some profit in opportunity. And also, since each time you will only order the amounts that you need for the new production plan, right? Then you have to order more time from your supplier compared to other rules, right? It will actually incur a higher setup cost or ordering cost. Okay, so that will be the downside of using lot for lot rule. Okay, so here I also list some of the key ideas related to what is the advantage and also what is the disadvantage of using each specific rule. If you have any question, feel free to let me know. Thank you.